We discussed about homogeneous functions. So let us write the definition. A function f in the variables x and y is said to be homogeneous of degree k in x and y if for any lambda f of lambda x lambda y is equal to lambda to the k f of xy. This definition simply tells us that if we are to replace x and y by lambda x and lambda y, and after simplification, we can factor lambda to some power k times f of xy, then we say that f is homogeneous of degree k in the variables x and y. So for example, we are given f of xy equal to x cubed minus 2x squared y plus 4y cubed. If we are to follow the definition, our x here will be replaced by lambda x and y by lambda y. And let us see what will happen. So f of lambda x, lambda y is equal to x replaced by lambda x raised to 3 minus 2 times x, which is lambda x squared, times y, which is lambda y, plus 4 times y, which becomes lambda y quantity cube. Alright, so we simplify. Lambda x to the power of 3 is lambda cube, x cube, minus 2. Lambda x squared is lambda squared x multiplied by another lambda, that will be equal to lambda cube, x squared y, and finally 4 lambda y raised to 3 is lambda cube y cube. Now the greatest monomial factor here is lambda cube. So factoring lambda cube, we get x cubed minus 2x squared y plus 4y cubed. And as you can see, this entire thing is equal to our f of xy. So we write lambda cube f of xy. So therefore we say that f is homogeneous of degree 3 in x and y. Let us have another example. Say g of xy is equal to the square root of x squared plus y squared minus x plus y. So g of lambda x lambda y is equal to the square root of lambda x squared becomes lambda squared x squared, and y squared becomes lambda squared y squared, minus lambda x plus lambda y. In our radical, we can factor lambda squared. So the radicand becomes lambda squared times x squared plus y squared minus lambda x plus lambda y. But the square root of lambda squared is lambda. times the square root of x squared plus y squared minus lambda x plus lambda y. We factor lambda, we'll be getting lambda times the square root of x squared plus y squared minus x plus y. Again, as we can see, this expression is exactly our g of xy. Right? That is exactly g of xy. So we write this as lambda g of xy and conclude that g is homogeneous of degree 1 in Xn.